Welcome to Session 11. By now you know all the angle rules: complementary, supplementary, vertical, parallel line angles, and the triangle rules. On the GED, these usually show up hidden inside a real-world situation: a ramp, a garden, a road, a clock. The trick is to find the simple relationship buried in the story, and then just add or subtract. Today, we'll practice doing exactly that. Almost every angle word problem fits one simple model. You have some known angle measures plus an unknown, and together they make a required total. That total is nearly always one of three familiar numbers: 90 degrees for a right angle, 180 for a straight line or a triangle, or 360 for a full turn around a point. Figure out the total, and the unknown is just a subtraction away. Here's a reliable three-step routine you can use on any problem. Step 1. Ask what is being formed: a straight line, a right angle, a crossing, parallel lines, or a triangle. Step 2. Decide which rule fits: complementary, supplementary, vertical, corresponding, or the triangle angle sum. Step 3. Add or subtract to find the missing angle. Name the relationship first, and the arithmetic becomes easy. Let's do one. A ramp meets the ground, and the angle on one side of it measures 25 degrees. What's the angle on the other side? The two angles sit together on a straight line, so they're supplementary. They add to 180. So the other angle is 180 minus 25, which is 155 degrees. Here's a triangular garden. Two of its corners measure 80 degrees and 55 degrees, and we want the third corner. The three angles of a triangle add to 180, so the third corner is 180 minus 55, which is 45 degrees. Same rule as always, just wrapped in a gardening story. Angles hide in everyday objects too. Think of a clock at 3 o'clock. The hour hand points right, the minute hand points up, and between them they form a right angle, exactly 90 degrees. Recognizing that the hands make a right angle is the whole problem. The secret to word problems is translating the words into geometry facts. Underline the clue words. Perpendicular means a 90-degree angle. Straight means 180. Parallel switches on the transversal rules. And isosceles tells you two angles are equal. Also watch for the phrase, "not drawn to scale." That's a warning to trust the numbers, not the picture. Sometimes you'll combine two rules in one problem. Imagine two parallel streets crossed by a road, making a marked angle of 125 degrees. A triangular lot uses the acute angle next to it. First, that acute angle is a linear pair with the 125, so it's 180 minus 125, which is 55 degrees. Then, if another corner of the lot is 65 degrees, the third corner is 180 minus 55 minus 65, which is 60 degrees. A linear pair first, then the triangle sum. Always watch your units and your context. Angle answers are in degrees. Lengths use linear units, and areas use square units. And do a quick reasonableness check. If a triangle angle comes out negative, or bigger than 180, or an angle you drew as sharp comes out as 140, then go back and recheck which relationship you used. Now, the most common mistake. Students dive straight into arithmetic without first identifying what the angles form. That's how you end up subtracting from the wrong total. Always name the relationship first: line, corner, crossing, parallel lines, or triangle, before you touch the numbers. Naming it tells you whether the total is 90, 180, or 360. Let's check your understanding. A straight line is split into two angles, and one of them is 25 degrees. What is the other? Angles on a straight line are supplementary, so the other is 180 minus 25, which is 155 degrees. Let's recap. Turn every word problem into the model. Known angles plus an unknown equals a required total. Ask what is formed, choose the matching rule, then add or subtract. Translate keywords like perpendicular, straight, parallel, and isosceles into facts, and always check that your answer's size and units make sense. Excellent work on Session 11. You can now unpack real-world angle problems with confidence. In our final session, We'll pull every rule together into one complete strategy toolkit for mixed problems.